Good evening everyone. In this video we will learn about the varactor diode. So varactor diode is simply a PN junction diode whose internal capacitance vary with the change in reverse bias voltage. It is also known as varicap diode or tunable diode. The term varicap refers to the variable capacitor and the varactor represent variable reactance. It means that as we change the reverse bias voltage, its capacitance or in other term its reactance will change. This is very important property and this kind of diodes are very useful when we want to change the capacitance in the circuit using external voltage. And due to this, varactor diodes are specifically used in RF communication system. This is the symbol of the varactor diode. It shows that it is the PN junction diode, but unlike the normal rectifier diode, it is intended to be used as a capacitor. Now to understand how the varactor diode works, first let's recall the parallel plate capacitor. So here we have it. It consists of two conducting plates separated by distance d or dielectric medium. Its capacitance is given by C equal to epsilon A by D, where C is capacitance, epsilon is permittivity, A is cross-section area of the plates, and D is distance between the plates. For the constant value of epsilon A, if we change the distance between two plates, or in other words, the thickness of dielectric medium, then the capacitance will be changed. And for the varactor diode, the concept is same. So here is the internal structure of the varactor diode. It is similar to the PN junction diode, but there is an extra layer, that is N+. It is not necessary to show it every time, but it is shown here for the drifting purpose. Here for this PN region, we can see that cross-section area is changing epitaxially. That's why this layer is also called epitaxial layer. Epitaxially means its width is changing exponentially. Now to understand how the varactor diode works, let's consider this PN junction diode. Varactor diode is also a kind of PN junction diode. In the PN junction diode, when we combine P and N type of material, then depletion layer is created like this. Here this P region contains excessive amount of holes and the N region contains excessive amount of electron, and the depletion layer is depleted with the charge carriers. So this PN junction behaves like the parallel plate capacitor, where P and N junctions behave like conductor and depletion layer acts as a dielectric medium. Now when we apply reverse bias voltage, the depletion layer width will increase. According to this equation, increasing in value of D will decrease the value of capacitance. In other words, capacitance C is inversely proportional to the applied reverse bias voltage. More specifically, this relation can be given by this equation, where C0 is the capacitance when diode is not biased, V is applied reverse bias voltage, and Vf is built-in voltage. The value of N depends on the doping profile of the varactor diode. So based on the value of N, there are two kinds of varactor diode. First is abrupt varactor diode. Here is the doping profile for the abrupt varactor diode. So we can see that at P and N type, doping concentration is uniform, but there is abrupt change in doping concentration at the junction. For this kind of junction, the value of N is equal to 1 by 2. Usually, the normal PN junction diode consists of this kind of junction. Next, this is the profile of abrupt varactor diode. From the plot, it can be observed that at the both sides, doping concentration reduces with the distance. For this kind of doping, value of N is equal to 2. And from this equation, we can observe that if we put n equal to 2, then there will be more change in capacitance with voltage compared to the abrupt varactor diode. The varactor diodes are optimized in such a way that it provides more change in capacitance with the voltage. So the equivalent circuit of the varactor diode looks like this. Here RR is the reverse resistance of diode and RS represents the ohmic resistance. Usually the value of RR should be in mega ohm because during the reverse bias condition only leakage current or reverse current flow through the diode. To minimize this current, the value of reverse resistance should be as high as possible. So this is the equivalent circuit at low frequency. But to operate the varactor diode at high frequency, we have to consider the parasitic capacitor, this one, and the inductance. So here is the equivalent circuit of varactor diode at high frequency. Now the applications of the varactor diodes. Varactor diodes are used in voltage control oscillator, frequency synthesizer, parametric amplifiers, frequency multiplier, tuning circuits, and phase dock loops. So overall, the varactor diode has broad range of the applications.